Okay, so today we're going to do area between two curves, but with y integration, okay? So you should be very familiar with doing the x integration, okay, when we're doing top minus bottom. Today when we do y integration, we have to do right minus left, okay? And we need to use y values when we do this. Now, sometimes the y integration is an option, but other times it's a necessary thing, okay? There's no way to tell which is the top function, or maybe sometimes we can't tell the bottom function, maybe because it comes to a point in some way. So, in this particular example, it's really either option, but I'm going to use this as a good example as to show you how to use the y integration. So I hope you're ready for it. It could be exciting and a little bit different, but kind of the same at the same time. So here we go. Okay, so first thing you're going to notice is that the equations given to us are x equals in terms of y. So that's kind of indicating to use y integration. Now, particularly this equation, because we can't solve for a single y, there's more than two, okay? So keep that in mind. I'll come back to that, so if you really want to still do x integration, you can, but let's graph this out so we can get back to that. Okay, so we go to graph out our equations, and saying it's just really in the first quadrant. If you want, you can draw the other quadrants just for like reference. Especially the first equation is actually the same as y equals the cubic root of x. So this is our common function. We should know how to graph. Okay, I'm going to keep this in a different color than the next one. Okay. So this is x equals y cubed. The right one I'm going to use a red. And this one, if you don't know how to graph it, figure out values for y that you want to plot and x. Okay, and then just plug them in. So -1, 0, 1, then we get these points here. Now you may think, hey, it's going to overlap on top. It doesn't really. If let's say y was 1/2, x would be 1/4. If let's say y was 1/2, let me change color here. Then x would be 1/8. So this one is closer to 1/2. Actually, it should be there. And when x was 1/4, let's say here, then it's 1/2. Okay, so the x equals y squared equation more or less comes this way. This is not the best way to kind of look at it, but this is true. This is the area that we're trying to find. Okay, it's just this little sliver. So the equation here is x equals y squared. So it's really helpful to have those different colors. Hopefully you can see what we're doing. Okay, so area. Integrate right minus left. Our right function being y squared. We want to keep things in terms of y. And our left function being y cubed. Don't forget we're going to integrate with respect to y. But that also means that we need y values here and here. So take a look at your graph to determine the y values. So the region kind of starts here where y is 0. And then it goes up to here where y is 1. Okay, so please be careful that you actually choose the y values. Okay, and then we can integrate. So it's similar as far as like graphing, writing an integral, but it's opposite because you have to identify right minus left and write everything in terms of y. Now everything is pretty much the same, just integrate with a different variable. So we get y cubed over 3 minus y to the 4th over 4. We're going to plug in 1 and 0, and we do just that to evaluate our problem. Okay, and I ran out of space, of course, so this turns out to be 1/3 minus 1/4, so this is 1/12. Okay, so the area is 1/12. And you can write square units if you'd like. Okay, I boxed it over there. So make sure you get that answer, and make sure you ask me if you have any questions, okay? Going back, if you do the positive square root, okay, then you can use top minus bottom, because you do see a top and a bottom for this one. But like I said, please be familiar with doing right minus left, because sometimes that's your only option, okay? It's not too bad. I think it's pretty simple. Just kind of follow through and write y's. All right, good luck.